The evolution of reflecting telescopes is a fascinating journey through centuries of scientific progress. Reflecting telescopes have played a crucial role in the advancement of astronomy, allowing scientists to peer deeper into space and expand our understanding of the cosmos. This description explores the history, development, and impact of reflecting telescopes, starting from their inception in the 17th century to the present day. Before the invention of the reflecting telescope, astronomers relied heavily on refracting telescopes, which used lenses to gather and focus light. While refracting telescopes were an advancement over naked-eye observation, they had significant limitations, particularly chromatic aberration, a type of distortion caused by the different wavelengths of light bending at different angles as they pass through the lens. This problem made refracting telescopes less effective for astronomical observation. The invention of the reflecting telescope is most commonly attributed to the famous English scientist Isaac Newton. In 1668, Newton built the first practical reflecting telescope, known as the Newtonian telescope. His innovation was a response to the inherent flaws in refracting telescopes. By using a concave mirror to gather light and a flat secondary mirror to direct the light to an eyepiece, Newton's design eliminated the issue of chromatic aberration. The Newtonian telescope was also much more compact compared to its refracting counterparts, making it easier to transport and set up. Newton's reflecting telescope, often referred to as the Newtonian design, was a major breakthrough, and it set the stage for future developments in optical astronomy. The use of mirrors instead of lenses allowed for larger apertures, which meant greater light-gathering power and more detailed images of distant celestial objects. While Newton's design was groundbreaking, the technology available at the time did not allow for high-quality mirrors, and early reflecting telescopes had limited effectiveness. The mirrors in Newton's telescope were made of metal, which tarnished quickly and degraded over time. In the 18th century, advancements in mirror-making technology were necessary to improve the quality and durability of reflecting telescopes. One significant breakthrough came in 1733, when British scientist Chester Moore Hall developed a method for making a glass mirror with a reflective surface. This glass mirror was more durable than metal mirrors, allowing telescopes to last longer without losing their effectiveness. Hall's work was followed by further innovations in mirror production, including the use of better metals and alloys to create more reflective surfaces. During the 19th century, reflecting telescopes became larger and more sophisticated. One of the most notable developments was the construction of the 36-inch refracting telescope at the Lick Observatory in California in 1888. However, the largest telescopes of the time were still refractors, and it was only in the late 19th century that large reflecting telescopes began to make an impact. One of the most significant achievements of the 19th century was the construction of the 40-inch reflecting telescope at the Yerkes Observatory in Wisconsin, completed in 1897. This telescope was the largest of its kind at the time and allowed astronomers to explore distant stars, nebulae, and galaxies in unprecedented detail. One of the key advancements in reflecting telescope design during the 20th century was the development of the Cassegrain system. This design, which was first proposed by French astronomer Laurent Cassegrain in 1672, uses a combination of concave and convex mirrors to achieve a compact telescope with a long focal length. The Cassegrain design became widely adopted due to its ability to gather more light while maintaining a relatively short tube length. In the early 20th century, astronomers began building larger and more advanced telescopes based on the Cassegrain design. These telescopes were often used for both professional and amateur astronomy, providing better images and facilitating more detailed observations. The second half of the 20th century saw the rise of space telescopes, which revolutionized astronomy. The most famous of these is the Hubble Space Telescope, which was launched in 1990. The Hubble telescope is a reflecting telescope with a large segmented primary mirror that allows it to capture images with unprecedented clarity. The Hubble Space Telescope was the result of decades of development and technological innovation. Its primary mirror, which measures 2.4 meters in diameter, was one of the largest and most advanced mirrors ever created at the time of its launch. It was designed to observe distant galaxies, stars, and other astronomical phenomena, and it has provided some of the most detailed images of the universe ever captured. The success of the Hubble Space Telescope spurred the development of other space-based telescopes, such as the James Webb Space Telescope, which is set to launch in the coming years. These space telescopes have allowed astronomers to observe objects beyond the reach of ground-based telescopes, overcoming issues such as atmospheric interference and light pollution. On the ground, one of the most significant developments in reflecting telescopes was the advent of adaptive optics. This technology uses deformable mirrors and computers to correct for the distortion caused by the Earth's atmosphere, allowing ground-based telescopes to achieve clarity similar to that of space telescopes. The first successful use of adaptive optics was demonstrated in the 1990s, and since then, it has become a standard technology for many large ground-based observatories. As technology continues to advance, the future of reflecting telescopes looks bright. The development of larger and more precise mirrors, along with advanced materials such as segmented mirrors, will allow for the construction of even larger telescopes. These advancements will enable astronomers to study objects further away and with greater detail than ever before. One of the most exciting developments in the field of reflecting telescopes is the construction of the next generation of ground-based observatories, such as the Extremely Large Telescope, ELT, the Giant Magellan Telescope, GMT, and the 30-meter telescope, TMT. These telescopes, which are being built in remote locations like Chile and Hawaii, will have mirrors measuring up to 30 meters in diameter, allowing them to capture more light and provide clearer images of distant galaxies, exoplanets, and other celestial objects. In space, the development of the James Webb Space Telescope, JWST, is expected to open new frontiers in astronomical research. With a 6.5-meter primary mirror, the JWST will be able to observe the universe in infrared wavelengths, allowing it to see through dust clouds and observe the formation of the first stars and galaxies. The JWST is set to complement the Hubble Space Telescope, providing astronomers with an even more detailed view of the cosmos. Reflecting telescopes have played an essential role in the history of astronomy. From their invention in the 17th century by Isaac Newton to the modern-day advancements in space and ground-based observatories, reflecting telescopes have enabled astronomers to peer deeper into the universe and make groundbreaking discoveries. As technology continues to improve, the future of reflecting telescopes holds great promise, with new telescopes poised to answer some of the most profound questions about the universe and our place in it. The evolution of the reflecting telescope is a testament to human ingenuity and our desire to explore the cosmos. It represents a journey of discovery that has not only expanded our knowledge of the universe, but also deepened our understanding of the nature of light, optics, and the technology that allows us to reach beyond the confines of our planet.